Welcome to Take 5 with Automation World. I'm David Greenfield, Director of Content, and today we're going to look at why industrial Ethernet protocols are still needed with time-sensitive networking. But first, to make sure everyone's on the same page, let's start by explaining time-sensitive networking, or TSN. Essentially, TSN is a way of providing determinism on Ethernet. And the lack of determinism in standard Ethernet was always one of the biggest drawbacks to Ethernet's use as a plant floor network. But since determinism is largely only required for high-speed or high-precision control applications, Ethernet's slowly but surely been gaining ground across manufacturing and processing facilities over the past 2 decades in all other areas of operations. Now, in areas where determinism is needed, deterministic field bus technologies have largely remained in place. And the reason why Ethernet lacks determinism is the way it handles the packets of information that are carried by it. So when multiple devices are communicating on a network, which is typical on any business network, Ethernet avoids data collisions, which can occur when multiple data packets are sent at the same time, by holding up some of those packets of information while others pass. Now, this avoids the potential loss of information when packets are dropped, for example, during a collision. Now, of course, this is a very simplistic explanation of how Ethernet handles data transmission without getting into the roles of routers, switches, and MAC and IP addresses. But hopefully it gets across the idea that some packets of data can be held up while others pass through. Now, for most information packets, this isn't a problem. For example, if it takes a fraction of a second longer for you to get your email, not only will it not impact your operations, you won't even notice it. But with this kind of delay, it can cause problems with high-speed and high-precision machinery. And that's where TSN comes in. TSN is an IEEE 802.1 standard originally developed for the audiovisual industry to better synchronize audio and video. But the deterministic communication it provides can be used for Ethernet-based control traffic because it ensures that critical control communications not only get through unimpeded by other traffic on the network, but that control communications are treated with the highest priority. Now, the first step in understanding how industrial Ethernet protocols function with TSN is to understand that TSN only addresses network functions at layer 2, which is called the data link layer of the Open System Interconnection model, often referred to as the OSI model. And Tom Burke, the Global Strategic Advisor at the CC-Link Partner Association, which supports the CC-Link IE Industrial Ethernet Protocol, says that because TSN only operates at this layer 2 level, it's only responsible for getting data from one place to another in a deterministic manner without looking at what the data is. That means that whatever needs to be done with the data transmitted via TSN is handled at the higher level layers that address specific application requirements. And this is where the industrial Ethernet protocols come into play. Burke says the protocols and TSN work together around convergence, as most industrial Ethernet protocols don't allow different kinds of traffic to be merged onto the same network. So TSN essentially creates a system that provides the necessary flexibility on Ethernet by allowing multiple traffic types to share the same network while being handled in a deterministic way. Now, Burke advises that for machine builders and end users to fully leverage the advantages of a TSN-compatible Ethernet protocol, they should look really closely at its specifications to make sure it can address the requirements of their intended applications. He stresses that a suitable protocol should encompass inputs and outputs, motion control, and safety. And Burke notes, of course, that CC-Link IE TSN is an industrial Ethernet protocol that combines gigabit bandwidth and TSN functionalities. The CC-Link IE TSN protocol uses layers 3 to 7 of the OSI model to build on the layer 2 TSN capabilities. Burke says that by doing this, it allows I/O, motion, and safety control to be integrated with standard TCP/IP traffic over Ethernet in a deterministic way. Now, in addition to CC-Link, i.e. TSN, other industrial Ethernet protocols that have expanded their technology for use with TSN include Profinet, EtherCAT, Ethernet IP, and even Circos, which has long been recognized specifically for its deterministic capabilities. So I hope you found this Take 5 episode helpful.